Section 8.2, Day 2, Dividing Rational Expressions. The essential question, write it down, please. How do I divide rational expressions? So in the last section, we multiplied them. We now are going to divide them. Recall that to divide by a fraction, you multiply by its reciprocal. And what I say is this: if you're taking 1/2 divided by 3/4, I call it keep, change, flip. So we do a keep. This is the change. We're changing that from divided by to multiplication, and we flip the 3/4. And then it turns from a dividing to a multiplying problem. So example 1, divide. Assume that all expressions are defined. First thing we do, because we are dividing, we do a keep, change, flip. That's the first thing I do. So we keep, change, and then I flip. X squared minus 16 on top, and the x to the 4th plus 2x cubed minus 8x on the bottom. All right, let's scroll down. Now, we already know how to do this. We did this in 8.2 day 1. We're going to factor each part. So, x to the 4th minus 9x squared, it's a binomial. There's a GCF, and that's x squared. If I take x squared out, I have x to the 4th divided by x squared, and 9x squared divided by x squared. And on the bottom, x and x, two numbers that multiply to 3, 3 and 1. They multiply to a positive 3 and add to a negative 4. So they both are negative. Over here, x squared minus 16, that's the same as x and x. 4 and 4 times 4. One's a positive, one's a negative. And x to the 4th plus 2x cubed minus 8x. Well, first thing is I can take out a GCF, and that is an x. And when I do that, I take out an x, I get x to the 3rd plus 2x squared minus 8. Wow, this one is a little tricky because I'm looking to see if I can cancel anything, but I need to factor it again. Because x squared minus 9, we can do x plus 3 times x minus 3. Leave this alone. And on the top, x plus 4, x minus 4. And on the bottom, we have an x you know what? I just remembered something on this problem. There was a typo on this problem, I remember. We need a squared there. That's all right. We're going to go back and fix that, which means that's squared, but that's going to change a couple things. Because if I take out a GCF out of here, it's an x squared. If I take out an x squared, then this is going to change to a 2. That is that. And there we go. That we needed to fix. Okay, so now we have x squared right there, and now I can factor. Again, x times x, 4 times 2, And we need the negative there and the positive there because they have to multiply to a -8 and add to a +2. Everything is fully factored. Now I see, what can I cross off? Well, let's start over here. I have an x squared on the top and x squared on the bottom. X plus 3, there's none on the bottom, but there's an x minus 3, top and bottom. X plus 4, top and bottom. And so what we are left with is an x plus 3, x minus 4, x minus 1, x minus 2. And there's our answer. Example 2, we're going to do in class along with example 3. And now we're going to go to example 4. So now there's different directions. Solve. Well, we're solving a rational equation. Same thing. Just like multiplying, just like dividing. I have to factor everything that I possibly can. So x squared minus 25 factors into this. And now I look at the left side of the equation. I have an x plus 5 on the top, but not one on the bottom. But those I can cancel. X plus 5 equals 14, and we just finished solving. Minus 5, we get x equals 9. The reason it says check your solution is because we have a rational expression. We have a fraction. And what we have to check is we have to look at our final answer, which was 9, and plug it back into the denominator only. And the reason is because you can't divide by 0. Well, 9 minus 5 is not 0, so we are okay. Our answer is x equals 9. Example 5. I'm going to solve that rational equation. Again, I want to factor everything that I possibly can. X times x, and I have 4 times 3 is 12. It needs to be a negative. One of them gets a negative, one of them gets the positive. I have to give the negative to the 3 and the positive to the 4, because when you add them, you need to get a positive 1. Another trick is look at your denominator. I know I'm going to have to cancel something, so 4 has to have the plus, and that's that. Add 3, x equals -4. If we take that -4 and plug that into our denominator, -4 plus 4 is 0. We can't divide by 0. When that happens, no solution in this case, because there's no other solution to check. All of them are crossed off, so it's no solution. And that's because if you plug your answer into the denominator of your rational expression, you get 0 in the denominator, and you cannot divide by 0. And I'm going to actually write something. It's a no solution because cannot divide by 0. Example 6, I'm going to say for class, video questions, divide. Small expressions are defined and solve.